Hey, it's Alex from Voiceflow, and welcome back to this case study series where we're going to talk about what we learned from launching an AI-powered Q&A chatbot for Hack the North, the largest hackathon in Canada. This is a go-to guide where you'll learn a blueprint for building real-world AI solutions, with everything from evaluation to building and then to deploying. This video will look at the second phase, developing the actual code for your solution. I'll walk you through the paradigms custom AI solutions built on Voiceflow usually follow, the process of both building the actual Voiceflow agent and the Slack bot that goes along with it, and taking a look at some of its code. Then we'll look at some of the challenges we encountered along the way and how we dealt with them, and then finish with an in-depth look at some of the code and setup for some of the most important features of this solution. So the first half of this video will be more presentation about the development process, and the second half will be going through some details of code in real time. If you haven't seen the previous videos in this series, I recommend you take a second to go look at them, because this video will build off the concepts there, but here's a quick run through of the case study so far. So Hack the North gets a lot of questions from participants during the event that could be answered in documents we already give them. We identified this as a problem that AI could solve with retrieval augmented generation and Voiceflow with an agent that could answer questions on Slack with a one-shot answering approach. We spent careful time writing a product requirement document and a technical plan, and then iterated and negotiated with the stakeholders to make improvements and add lots of security features to our bot. And now we're ready to program. So let's get straight into it. Okay, so the first technical thing we'll look at is a little bit of a recap of the architecture and the paradigms we're working with this Voiceflow project. All Voiceflow projects will obviously have to have a Voiceflow agent that's actually running the AI process, an interface that you're interacting with, and then some external services or knowledge-based information that you're actually using to run the logic of your agent. So this can be either calling your own proprietary APIs, calling databases like Airtable, or uploading documents you have prepared in advance. So here, we can take a look at the architectural diagram that's prepared for the Hack the North Q&A chatbot project. It looks a bit chaotic, I agree, but we can see things segmented between Slack the platform, the Slack bot in the middle where everything's running through, Airtable, Voiceflow, and our Hack the North Hacker API where we're getting scheduling information. So important things to note here in our architecture is that we're following a one-shot answering approach, as we talked about in the first video of the series, which means that there's no actual state inside the bot itself or database that we're reading from, with the tiny little exception of sometimes getting a little bit of information from Airtable, but we don't want to be relying on that for our architecture of our bot. So walking through what's here a little bit, generally we can see that things start with Slack, where users send messages either in the questions or the announcements channel. They then get sent to the Slack bot in the middle of the diagram. Then once we're there, the Slack bot will pass information to Voiceflow. Voiceflow will determine the question, and will answer it. The answer will then come back to the Slack bot, will be saved as a transcript, will be sent off to Airtable, sent to monitoring, and the answer will be given to the user. On the announcement side, the announcement just directly passes through the Slack bot, is added to the knowledge base and to Airtable, and then an acknowledgement goes back to the announcements channel. One important thing I want to point out here is where are we interfacing with external services? Here are the two big external services we're working with, our Hacker API for scheduling information, and Airtable for storing logs and analytics. When you're making an AI solution with Voiceflow, you need to decide, is my external service going to be interacted with from inside Voiceflow or through my interface or my own custom code that is hosting the main solution? So here we actually use both. Scheduling information is retrieved from inside Voiceflow. We actually have a Voiceflow function that is then calling Hacker API for schedule and getting an answer back. But on the other hand, we decided that everything that is Airtable and analytics will be handled by the Slack bot. It would be equally valid to also handle the Airtable and analytics through Voiceflow itself, but we decided to do it like this because more of the information we wanted to be storing in the analytics was related to the messages and all the information on the Slack side, rather than what's happening inside the Voiceflow side. But what we could even do is interface with Airtable through both. We could upload partial analytics from inside Voiceflow and upload some more information from the Slack bot if we wanted. But in the end, it's up to you to decide where you want to be interfacing with your external data. So now that we have an architecture laid out, let's take a look at the actual development process. So the first thing I did in my development process was make a very long list of steps I needed to do to fulfill all the features I had to develop. I just made this one in Notion. So since we know we're going to be building with Slack, we better get started with that. So for this project, we're going to be using the Bolt framework made officially by Slack exactly for developing applications. And then we went to the API section and made our basic app and got some credentials for it so we can add it to a workspace to be testing. Then I followed Bolt's Get Started guide to make the basic boilerplate that I needed to have my bot be able to just echo back whenever message is sent. But it did confirm to me that it's working, and it was actually not a lot of code to just get it set up. And here we can see it actually working inside of Slack. At just the start, I was saying hello, and it was echoing back with a ping. So that's great. Now the Slack interface is up and running. The next thing I did is set up a very basic Voiceflow agent. If you didn't know, you can look at the history of backups of your Voiceflow agent from the Settings and Backups tab, and from there, you can preview old versions as well as download them. So here we can actually see a preview of one of the first versions of my Voiceflow agent. All I did was capture the user's reply and echo back. And then we can see a little bit lower that I got it connected to my Slack bot, and it was able to echo from Voiceflow. So that's responding, "Hi there, Echo. This is testing if Voiceflow gets my answer." That's exactly what's happening inside the Voiceflow bot. I was able to connect that using a little bit of code that I wrote. So here's an example from my actual end product where I had this Voiceflow interaction function, and I'm able to call the Voiceflow APIs from inside my Slack bot to be able to send a request and interact with my Voiceflow agent, and then get its response and parse it. We'll be going through all the exact details of how this code processes questions in the second part, but all you need to know here is that I have set up a Voiceflow interaction system, and now I'm able to get a basic back and forth between Slack and my Voiceflow bot. So now that this groundwork is set up, I can focus on improving my Voiceflow agent. We know that most of what we're going to be handling here is knowledge-based type queries, so that's what I put my attention towards first. So here's the next version of my bot, where I'm getting a user's reply, looking up in the knowledge base, and then if it succeeds, I'm going to tell them the answer, and if it doesn't succeed, I'm going to tell them, hey, I wasn't able to get it. You can also see at the bottom that I added a comment explaining how I want this knowledge-based lookup system to work, and I added a couple custom actions at the end to denote if the answer was a success or a failure. We'll go more into those in the analytics they provide in a second. Next, I worked on fleshing even more out my knowledge-based lookup system. I knew I wanted to prioritize announcements, so I wrote some custom functions for that, had some moderation set up to make sure that users aren't trying to break my bot, and at this point I had a pretty built-out KB lookup step. But I knew I wanted to use it in lots of different places inside my Voiceflow project. So I turned most of this into one little component, which brings us to what we have here, a quite simple looking knowledge-based lookup step that actually has two very powerful components, both in the announcement lookup here with this component diamond and in the ability to score and finish. So by this point, I had put a lot of work into iterating and developing the actual Voiceflow agent itself. And now I started work on adding actually a couple more workflows for more specialized tasks that I wanted my agent to be able to do. So let's take a look at these now and at the final stage of the entire bot. So from my Voiceflow project here, we can see I had a couple different workflows. So home is the most basic one. It's for knowledge-based lookup. We also have emergencies, judging, locations, and real-time scheduling. Let's start off with taking a look at the home step, which is the main knowledge-based part of the agent. So from here, every conversation starts with telling the user we're ready for the message. That's because in our Slack interface, right, the user is speaking first, but in Voiceflow, the agent always speaks first. So we're just going to launch a conversation and then throw away its first answer, and then capture our answer from the user. And then we hit our smart announcement knowledge-based component. This component's actually really powerful. It's that big diagram that I showed before of some knowledge-based lookup steps. The way it works is, first of all, there's a moderation step that just checks if the question is relevant for an AI to be answering. So this avoids jailbreaking or malicious attempts from participants trying to break our bot, and just uses an AI set step to try and evaluate is the answer good or bad, give an output, and then go down a path. So if it's not relevant, we're just going to say, hey, I'm not able to answer that, and then go down this stop path. If it is relevant, though, we're then going to go to a step that fetches announcements. So this is just a way with Voiceflow, you can actually call your knowledge base using the API. And calling with the API is really powerful, because here I'm able to actually only fetch documents with a tag equal to announcements. So this lets me make sure that I'm only looking up announcements. And just for some context, our bot is going to be able to take announcements sent in Slack and actually add them to the knowledge base to have more up-to-date answers that are more factually correct. So we want to be prioritizing those over other older documents in the knowledge base, especially because some of the announcements might contradict past information. So it looks these up and just does a little bit of processing and formatting. So it gets the time of the announcement, makes a nice string out of it, and adds it to a list that is easy for the AI to handle. So this is what the announcement lookup does. But then in here, it will say whether it succeeded or failed to find some documents. If it succeeded to find some documents, we might not know if they're extremely relevant documents. So the next step we just do is ask the AI, hey, here's a list of documents we got. Are they relevant or not? And if they are, we'll keep processing them. And if we're not, we're just going to fall back on a basic knowledge base step to just look up any information we have and then send it back to the user. If we did find some announcements that are relevant though, we're then going to specifically look up non-announcement documents. So using a similar method here, we're looking up documents with a tag that exclude announcements. So to make sure that we're not getting announcements, we're going to store that also in a variable. And then we're going to tell the AI, hey, we have these announcements and some previous text. The announcements might contradict the previous text, and we want you to take into account the announcements as most important and give one final answer for the user. So that's what's happening in this long prompt here. And don't worry, it took me a long time to write this prompt and iterate on it. I mean, I definitely recommend that you iterate too to have a good balance of the kind of quality of answers you want to get out of your agent. Here it puts a special focus into making sure that the answers are long because we only have one shot to give an answer. So we want to make sure we're fully answering the user's question. You'll notice here that the exit actually has a last set step. This actually sets a variable called smartKBSuccess to either true, false, or stop, depending on how this smart announcement component ran. So obviously, if we had to abort early because it's an irrelevant question, it's going to set the variable to stop. If it succeeded, which means either finding a document in this step, or it means having a synthesized answer with announcements and old information, we'll set it as true. And otherwise, we'll set it to false if it wasn't able to find any documents. This is useful because from inside our Voiceflow agent, we're then able to go down different paths depending on how the component ran. Because by default, components only exit and continue down to their next step without having conditional or different branching paths. So having a variable that you can reference to know which way to go is really useful. By the way, this whole template for the Voiceflow project will be available in the GitHub linked in the description below. So after this, we're just going to speak out the output of this smart knowledge base lookup. So that's just a text step here. And then we're going to score and finish. So this score step just gives an AI score to the quality of the answer. Taking a look at some of the other workflows, let's look at real-time scheduling. This one gets information from Hack the North's Hacker API to supplement answers with up-to-date real-time information. This is because there's a ton of scheduling information for the event, and we found that if we just upload it all to the knowledge base or give it all to the AI, it gets a little bit overwhelmed. So what we're doing here is actually really cool. We're going to be using some JavaScript to extract the current time. Here's just some testing stuff because we're not during the event, so it would break otherwise. And then here we have an AI prompt that gives an AI the expected schedule of the event, as well as the current time and what the user is asking to determine when it should look in the schedule. Should it look in the past? Should it look around now? Or should it look into the future? Then, based on its answer, we're going to go down different paths. And we're actually going to call our Hack the North Hacker API with different time windows. So here we actually have a custom function that calls our own API. Here's the link, and here's some GraphQL we're sending to the API. And I think this really showcases Voiceflow's versatility when it comes to integrating with whatever service you want. You can even integrate with your own proprietary services. Once we got the answer, we're actually just going to send it to an AI to generate a scheduling answer, and then we're going to use the same knowledge base lookup to look up any past information that might also be helpful. And then we synthesize it together into one big answer if something was found in the document lookup. So there's a big prompt here that just tells the AI like, hey, you're going to mix these two parts of information. And if there isn't any older information found, it'll just directly spit out what the scheduling answer was. Same way, it'll score an answer. So we can see here that by using different workflows, we're actually going down different paths and doing different processing to give our AI answer. A similar thing happens for locations, where if we have a location question, we're actually going to look up the information in the knowledge base like we usually do. We're going to send it out, and then we're going to use AI to determine a map that we should give the user so that we can have different types of maps, like an area map, an outdoor map, a sponsor map, a sleeping map, and then things like that. And then based on the type of map it selects, it's actually going to send an image to the user to augment the answer. So this is again another way we can upgrade the behavior of our agent by adding visual information other than just text. The last one I'll go into now is the emergency system. This is just so that if anything is going wrong or something that either the AI can't answer, a participant is hurt, or something is going wrong, we're able to give them a more structured answer, not looking up in the knowledge base, just giving them maybe some emergency contact information, and then telling them that organizers will be on their way to help as soon as possible. So all of these different workflows are actually powered by Voiceflow's intent system. We've created a bunch of different intents for what the user might want to be asking about, and each of the different workflows is triggered by a different kind of question. So now that in the development process we've really fleshed out the behavior of our agent, we need to populate it with content. This is where you want to fill out its knowledge base with a bunch of useful information you have. Here, for example, I uploaded some past documents we've had from previous hackathons, like our hardware tool information, judging instructions, a welcome booklet, and some FAQs, as well as adding a bunch of announcements that lets us really see our agent in action. And then we spent a little bit of time modifying the sim prompt for the knowledge-based lookup just so it's a little bit more consistent and aligned with what we wanted out of it, like not giving markdown and giving long and clear answers. After this, we went back to the Slack bot to improve its interface a little bit. So you can really see the alternating between Slack, working on Voiceflow, working on the Slack bot, working on improving the Voiceflow agent to be more complex, and then coming back to the Slack bot to make it more powerful. So here, now that we added images to our Voiceflow agent, we need to be able to handle them from inside of Slack. So that happens in this part of the code where we're actually able to add attachments to our message. So we're checking for traces that are visual and that are images, and then we're adding an attachment with the image URL sent from Voiceflow. One thing of note here is that when you're working on a custom AI solution made of Voiceflow, you're going to need to handle these different kinds of traces differently. So here, text is very basic. We just add it to the message output. But images we need to deal with differently. And if, for example, you wanted to add buttons or carousels, you need to make a decision on how you're going to show those in your interface. And that will come out through some conditional code when you're iterating through the traces that you're getting returned to look for text or visual, or here custom actions like answer, just so you can handle them properly. For a deep dive technical walkthrough of all the reasoning and logic behind working with this, you can find a full walkthrough video that's in the description below. The last big thing I did in the development process for this MVP was do a refactoring of the project just to make it all clean before quality assurance and I get some code review. Because the structure of it wasn't that great, it was more like 1 or 2 files. But after that, I wrote a little README, and it's going to be ready for code review on our GitHub, and you'll actually be able to download this project on the GitHub linked in the description below when it's fully open sourced. Here's also a few other tips on using components, templates, JavaScript, and functions in your Voiceflow project to build something both really powerful and build quickly. So here in my project, I'm actually using components in a couple of different ways. So components is really powerful because it lets me rerun the same steps and blocks, but from different parts in the code. And if I update the component once, that update is represented everywhere that it is used. I'm using them both for the knowledge-based lookup and for the scoring and finishing, which just has a little bit of AI prompt engineering, and I want it to be consistent between my different workflows. So now with these components developed, I actually made some template elements out of them. So you can think of template elements more like copy-paste, but they're really powerful if you're going to be building a large agent. So here, this smart knowledge-based lookup, actually it always requires both the component that does the actual lookup and this conditional step that goes down the branching paths. So to be able to have the consistent block, I actually made a library element called knowledge-based lookup that we can use here. And it has both a fail and pass path, and then if it does pass, it automatically speaks out the answer. So this just really speeds up the development flow and helps me keep things consistent. I also use library components for the answer fail and for the answer success ending outputs, because those let me have a consistent formatting for the action that says, hey, something came out well. Another thing I make use of inside my project is both JavaScript and custom functions. They're both useful for doing different kinds of things. A JavaScript step on its own is really useful for just doing some slightly more complicated variable assignment than you can do with a set step. So here I have some super basic JavaScript that just makes a debug message out of a string of variables. But we're also using JavaScript in other places. Like, for example, inside the scoring and finishing, we're actually getting the AI to give its reasoning and then give a grade in a certain format. So it's a squiggly, grade, colon, a number, and then a squiggly. And we want to be able to extract that well. So there's no need to write a whole big function for this. We're actually just able to use some simple JavaScript with regular expressions to match for this grade and then extract it and then assign it to our answer score variable. So this doesn't need a full function. But on the other hand, functions are useful for some things. So here we saw 3 functions that I'm using. We saw the hackathon scheduling lookup, which does use quite a bit of code. It formats a GraphQL query, has to do lots of processing, which we wouldn't want to do from inside a tiny little JavaScript step, especially because we're going to be reusing this code in multiple different places. In the end here, this one was used 3 times inside the real-time scheduling for those 3 different time windows. So that's why it's useful to have it as a function because it's larger and reused. Similar thing for the functions that were used for the announcements and non-announcement lookups. That's just because we want to be doing some processing and we're going to be calling an external API with more parameters than we want to do with a basic either API step and then some JavaScript after. It's just much nicer to put it in a nicely wrapped function and that you can just work with easier. Okay, so now let's take a look at a couple of the challenges we encountered during the actual development. So the first of them was the issue of how we're actually going to get the user's question. This might sound like a little bit of a dumb challenge, but it's less obvious than you might have expected. Normally, voiceflow conversations happen with voiceflow talking first, then getting users' reply, then giving an answer. The issue arises that in our scenario, it's actually the user starting first. The user will send a message in Slack and we need voiceflow to instantly answer. Then we ask ourselves, how do we get that question to voiceflow best? My first idea was that since we didn't want voiceflow to have a turn first, we can send some information with the launch payload, which is what you actually send when you're starting a conversation inside voiceflow, and then have it handled that way. So if you didn't know, like I've shown on screen, it's sort of this top part. When you send a request, any request, be it launch or any other interaction, you can specify a payload. You can then get that payload if you look inside voiceflow for the variable called last event, then get the last event's variable called payload. From there, we extracted the message if we had one and stored it in a variable called question, and then spoke the question out, and that's how I was echoing and doing some answers inside the knowledge base flow. I then came to the realization that I wanted to actually be using the intent system to be able to categorize what direction to go down. So is it an emergency? Is it a scheduling question? Is it a location question? Or is it just a basic question? And using the intent system requires having the information sent to you as a text interaction. So the way I solve this problem is that I actually have the system send a message that says system ready for question. And actually I throw that away. So whenever I start a conversation, I'm actually doing two steps. First, I'm launching the conversation and getting that reply that I immediately throw away. And then I send the user's question as if they had sent a message, which then lets it get its intent categorized and go jump to that workflow specific, but otherwise is handled like any other interaction. Plus, it has the bonus of automatically being added to the last utterance variable that we can easily use anywhere and add it to the memory in case you wanted to have that for some reason. But in general, it's useful to know as a voiceflow developer that you can both be sending payloads with the actual message itself, but also through the last event, which can sometimes help you send more useful information like the platform the user's on, their email or user ID if you're connecting to accounts on a website, for example. The next challenge we found is actually just getting good answers out of the agent. Here on screen, we see one example where I was asking it, can I 3D print? And it would give me a one-sentence answer. You can 3D print up to 3 things at once. I guess that answers my question, but it's not super clear and doesn't give all the information I want. I'd be pretty disappointed if that's the answer I got from a really advanced AI bot. What turned out to be the problem is that the basic knowledge base prompt, if you actually look at it from inside VoiceFlow, has instructions to keep its answer as brief as possible. So the solution to get more broad answers was to engineer that prompt a little bit more and explain to it that, hey, actually, you only get one shot to give your answer, so I want you to give the biggest answer you can that integrates all the information you have to answer the user's question the most thoroughly possible. And here on screen, we can actually see the great impact. The answer goes from maybe a 2 or 3 on 5 to a 5 out of 5 great quality answer that not only answers the user's questions, but also gives them all the information they could possibly want if they wanted to learn about 3D printing at Hack the North. The next challenge I encountered was bad filtering. Like you saw when we were walking through the knowledge base lookup step, there is a filtering phase that I wanted to add to make sure that people aren't trying to abuse our bot, especially not to have it writing code for us or any other things like that. The issue was that it worked a little bit of the time, but very often I was having difficulties and it was actually blocking me on a question that I thought should be answered well. I tried multiple different times to re-engineer the prompt and explain my reasoning more clearly on what's allowed, what's not allowed. But then in the end, I got so frustrated with it that I just cut it out and hoped that any question that would be abusive or broken would just not be found in the knowledge base and the bot would just say, hey, I can't find the answer to that. In the end though, I talked to some people and actually realized that I should be asking the AI to give its reasoning behind its answer to maybe understand it a little bit better. And then it came to me. I had actually had some bad phrases that the AI was supposed to output. Because the way I'm able to figure out whether it's abusive or not is that I'm actually able to check the reply for a certain string. So here I was checking for yes or for no. And those are pretty vague variables, so the AI understood them differently to how I understood it. I took it as yes, it's okay, or no, it's abusive. But the AI on the other hand said no, there's no abuse, or yes, there's abuse. And that was actually the issue that was found, right? There's a lack of alignment between me and the AI. So what I did is I explained it a little bit more and gave the AI some more obvious flag phrases to give back, like good answer or bad answer. And I put some symbols in there and then did a little bit of more parsing. And plus, I told the AI to give its explanation so that its rationale is more clear, which is especially useful when its answers are wrong, because that lets me see how did it misunderstand my prompt and what should I change so it can answer better. So once I made all these fixes, I've put it back in, and ever since I haven't really seen issues with this moderation step, so that challenge was resolved. The next challenge I encountered was around the buttons. As I mentioned, we don't want our Slack bot to have a state or to be looking up into the database a lot. But that meant that when it came to the buttons, I had to figure out two questions. Based on which button is clicked, how am I going to figure out which record I should update in the database to say, hey, this is the answer? And how do I check that the user who clicked it is the user whose original question it was? Because one of the requirements for the feedback step was that the only person who could give feedback was the person who originally asked the question. That might sound like a really simple solution, but it's actually a bit more complicated than that when your bot doesn't have any state. But the solution to the challenge was actually adding a payload to the buttons. So you can see on the code on the right of the screen here, each button inside of it has an action ID. This identifies what kind of button was pressed. And inside of that, I added a payload that's a string with two values. The first value was the user ID of the person who asked the question. So let's say Alex asked the question, it would store the user ID for Alex in there. Then it would also store the corresponding record ID inside the Airtable database. We didn't want to be reading information from the Airtable database, so I didn't want to look up like, hey, for this user ID or for this timestamp, what's the record? So I'm actually just storing the record in there with a line in between the user ID and the record, so that whenever the button is pressed, I'm able to get the type of button and then extract the payload and then split it apart and check the user ID and the record, so that I could then say to Airtable like, hey, I want to be updating this specific record without having to do a lookup before. The last little challenge I encountered was actually more of a logistical issue. I really like this map module, but when talking to my logistics team, they informed me that they weren't actually just going to have one indoor map, they were going to have a bunch of different floor maps. So the issue here was that the original setup wasn't made for this. It was just going to serve one indoor map. We actually had an improvement happen late in the development of this, that if we want an indoor map, the AI is actually going to try and select a floor using some descriptions of what is on each floor and the text that was looked up, and then show different people pictures of different maps. So for now, we don't actually have the map, so it's just numbers, but it's actually really powerful to give users high quality maps to answer the question they're using. And now that we've seen some of the challenges that were encountered and how we solved them, we're going to take a deep dive into a couple of big features, starting off with how we handle sending questions from Slack to the bot and then getting the answer back from the bot back to Slack. So end-to-end for questions, whenever our app gets a message, so it's subscribing to any message that's sent in a channel where the bot is, it's going to check, is the message a question message? So this is sort of dispatching all the different kinds of messages that we're listening for. We're especially listening for questions, announcements, or knowledge-based insertions. Announcements and knowledge-based insertions are similar, and we'll talk about them in a second. But what we're doing is, if it's a question and it's not in a thread, we're going to send it off to a function called handle user question and send the message along with it. So from in here, we're going to add a reaction that shows a robot face to say, hey, we're pending. And then we're going to do some processing. So we're going to extract information about the message, and then we're going to send that first launch request to Voiceflow with a function I wrote called Voiceflow Interact, which just runs on the Voiceflow Interact endpoint and then returns the answer. Then, once we started the conversation, we're going to immediately send that follow-up with the user's question as the message sent through Voiceflow. So message.text is how we get their question. So that's what I sort of meant in the diagram when there's that first sacrificial system ready for message, and then we send the message instantly after. Once we do that, we also save the Voiceflow transcript so we can look at it later for all those debug logs. And then we parse through all the traces. So we look, is this text? Is this images? We also handle the end reason, which is the last thing that will happen in all of our flows to diagnose what kind of topic, did it go well, did it go badly, is there a score associated with this that we should be tracking? So we just handle that here. And then we're going to be sending the output text back as a reply in the message thread, which is again, a little function that I wrote that just takes the message, the output text, and any attachments you want and send it to the user. And then we're going to send a message to the monitoring channel for visibility. So we prepare this big monitoring message and then post it depending on the different types of exit reasons. So if it's an emergency, we'll send some sirens. If it's a failure, we'll send a warning sign. But if it's just success, we'll send this good check mark. And then we add some information to the Airtable. So we create a conversation record. This is, again, a function that I wrote that just takes in some information and then creates a record on Airtable. And then if it failed, we're going to send me a notification so that I can go fix it. And then the last thing we do is we send those satisfaction buttons which say, hey, was this a good answer or a bad answer? And in there, we're creating this button payload that I talked about in the challenge section that stores both the user ID and the record ID to be updated when they press the button. So we send those buttons along, again, in the same thread with the message and the button payload. And then after that's all done, we're going to remove the robot face so that we're done handling the message. So that's end to end. We're hearing the message in Slack, sending it to Voiceflow, getting Voiceflow's reply, doing the processing, and then also sending the monitoring and the analytics to Airtable. Next up is the end-to-end behind adding announcements. So this starts off similarly to how messages are handled. So first we hear a message, and then we're checking, hey, was this sent in the announcements channel, and is this not a thread? Again, we only want top-level messages to be handled as announcements. If it is, we're going to send it to a function called handle announcement that takes in the message and also the channel it was received in. This is because we want to be able to handle announcements and announcement-like insertions just the same. So if there's a discrete channel to also add announcements, we're just going to add the channel as manual insert so it can be distinguished differently, but otherwise it's just the same function. So here from inside the handle announcement, it's actually not that complicated. We're adding that same robot react message so that it's showing, hey, I'm processing it. Then we're going to run a Voiceflow function that adds the information to the knowledge base. So this is slightly different to the interaction. The first thing it'll do is it will call the knowledge base API and actually add some tabular data. This lets us have some additional information hidden as metadata and makes searchability easier. So we're just adding an announcement, and the announcement will have the text that's said, and as metadata, we're actually going to store the time at which it was sent. That metadata is really useful because then we're using it later inside of Voiceflow when we're looking up announcements to be able to label the announcement and the time it was sent together for more contextual information and so that we can sort found documents. Then, once that's added, we're just going to do a little bit more processing to add a tag. That's a tag that lets us uniquely identify, hey, this document we just added, it's an announcement so that when we can look it up, we're actually prioritizing it over other types of documents. So here we just do that, and there's a little bit of retry logic in case it fails, but not that complicated. We're just adding a tag here. So the tag's attach endpoint for the document ID, and the document ID, we get it from the add response. So like we add it, Voice will tell us, hey, this is the ID for the document, and then we say, hey, you know that document you just gave me? Add a tag to it. Back inside the announcement handling, once we added it, we're going to have the response and the success. So we're going to assume that's a success. If it is a success, we're going to send a message to the channel saying, hey, by the way, I added your document. And if it failed to add it, it'll send a message. And if it succeeded in adding the document but failed to add the tag, it means the information is still there, but it won't be prioritized the same way as the usual announcement. So it'll tell them to reach out to me, the maintainer, just to update that and check the logs to see what went wrong. And then lastly, we're just going to remove the reaction message. But the most important thing is that this document has been added to our knowledge base and is actually instantly ready to go. Once Voiceflow has processed the document, it can be found in any subsequent knowledge base lookups without having to republish the agent or anything like that. The last thing we're going to talk about is how we're handling analytics inside of Airtable. The reason we actually have this is so that after the event, we can have a large database of all the questions, all the answers, and do some more lookup on the time to respond, the cost, the success rates, the user feedback, and the answer quality ratings given by the AI. So other than just the monitoring channel, which is for in real time, we want to be able to look back at the database after. Before this, we need to be adding information to Airtable. So from our code, we actually have an Airtable script that I wrote that can create records both for conversations with a bunch of user information and for announcements with a bunch of announcement information. This is then being interacted with through the Airtable APIs. We could have used their SDK, but it just worked out fine doing it like this. And we have our own API key to be able to add it to our databases. Then once all these fields are added, we also have a different function to update the records so that once the user has pressed the satisfaction button, it's able to say, hey, This is how satisfied they were. We want to go update that previous record that we already had found. And we'll talk a little bit more about some of the experiments we run that really leverage the analytics data sent to Airtable in the next video. We really powered through that last section, looking at how some of the features were implemented. If you really want a deep dive, full technical walkthrough with all of my explanations behind all the reasoning and scouring through every single line of code, look for the full hour-and-a-half long walkthrough in the description below. Okay, now at this point, we've built out the solution originally outlined in our product requirement document. It works well for playing around with it, but it definitely needs to be thoroughly tested and benchmarked against our success metrics and prepared for actual launch. That's what we'll talk about in the last video of this case study series on deployment and iteration. We'll be talking about QA for AI products, debugging methods with Voiceflow, iteration, and preparing it for the actual real event. So I'll see you in video 3.